Hello, everyone, and welcome back. Hope everyone had a good weekend. Oops, I forgot to label this. Um, this should be called not Math 1.6. Uh, no, where is the dash button? Where is the dash? There we go. Exam zero review solutions. There we go. All right. Hopefully you guys saw my email over on Friday showing you that we had the exam review problems and along with their solutions being posted. As a little tip about mathematics, in my experience, and I want to tell you an anecdotal piece of evidence here. So, of course, anecdotal doesn't mean it's true for everybody, but it was true for me. When I started taking calculus at UW, they have on their website, UW's website, they have every teacher that teaches there, they have to post their old exams along with along with answer keys and or solution guides. Just so we're clear, an answer key is just the answers, whereas the solution guide is showing you how to do the answer, how to get to the answers. So this is the solutions. The answers are on the back side of the review. So they would do that. And so when I was studying for my first exam there, I was just looking at the exams and I was just reading their solution guide. I was like, that makes sense. That makes sense. That makes sense. I got this. Guess what happened? I did not do well. I did not do well because there's a difference. There's a difference between looking at someone else's explanation and doing it yourself. Because if you're looking at an explanation, that is someone else telling you how to do a problem, and they're showing you all the deductions, and it makes sense because you're seeing them perform it in real time. However, on an exam, that's not going to be the case, right? Because you're the one having to create this stuff off the top of your head. So my recommendation is always, always, always to attend, like study up. This is the way, like after that, I made a vow on that situation and tried to change the way I studied. And so the way I do it now is I study beforehand, then I do the review, and then if I get them, like I check, like as I go through it. So question 1A, I get blah, 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 blah. I check it with the answer key. If I got it right, awesome, move on. If there's a lot of questions of the same type, if I get like 4 or 5 right in a row, I'm like, okay, I probably got this on lockdown. Let me move on to the next thing. And if I have time while studying, I'll go back over them. But as soon as I get a problem wrong, I look at the answer key and I see I got it wrong. I go back and I try it again from the and I don't look at my old work. I think I talked about this in this class. When you're trying to redo a problem, do not look back at your old work. It's just a recipe for trying for falling over the same trap. So I try it again with a fresh with a fresh piece of paper. If I get it wrong again, that's when I try and look at the solution. And after looking at the solution, then I try and recreate it myself without looking at it again so that I know how that I'm making the connections in my brain. I looked at the solution key to see how it was done, and then I let my brain make the neural connections to figure out how to do it. That's just me. And obviously, one thing I will say, I'm not immune to it. I know that this is not the only thing going on in your guys' life, right? You guys have other things going on, but if you can study that way, that seems to be the best, most efficient way to me. Um, but either way, it's posted. Please feel free to review them and ask any questions. Email me about them, anything you have. Our first exam is this Wednesday. And remember, as soon as you get it back, you have a full week to do a redo. I think we talked about it a little bit in this class. Maybe it was the other class who was asking a lot of questions about it. But basically, I'll hand it back to you. There'll be little to no grading on it. It'll just have check marks or X's and telling you a score. You don't have to redo every problem. You only have to redo the problems that you got wrong. And you don't have to redo all the problems to turn in a redo. So if you can't figure out how to do question 6, but you figured out everything else, you can still turn it in. And you don't have to worry about you're not going to get penalized for not doing the whole thing. You can still get 50% of the points back on any of the other problems that you did. Okay? Cool. Oh yes, JT.
Did we do we take it back over question?
Yes. Okay. So excellent. So we're going to take the exam in here in class, like normal time period. I'm going to make them an hour and 20 minutes. So we have an hour and 50 devoted to us, but I'm gonna give it to I'll be on an hour and 20 timer just because the final exam is going to be it's departmental and it's for all Math 126 and 126Es. And since 126 is on a 1 hour 20-minute schedule, I want to make sure it's consistent with them. So we're going to be on a 1 hour 20, and then after I grade it, I'll hand it back to you, and you can work on it whenever you see fit. So you have a full week whenever you want to do it. If you wake up in the middle of the night 3 a.m. and say, I figured out how to do that problem, do it then. That's fine. But you don't have to you don't have to be on a time limit or anything like that. It becomes basically homework. Do it at your own pace. Good question. Good question. Okay. Any questions other than that? Okay. So we left off, we were talking about how to solve polynomial equations. And we started doing several of them. And then I gave you all the answers to these, but now let's go ahead and work through them together. So this first one, let me just actually just move these to the side here. Just oh, and this was supposed to be positive 5m cubed. That's right. We'll get to it. And then put this one over here, just get it over to the side. And then let's zoom in so we can actually see what we're writing. Okay. So 0 equals 2t squared plus 20t plus 2. First thing we should always do. So at the core of every solving polynomial equation, you have to use the zero product rule. Because the zero product rule is how we're going to be able to solve the different linear equations that we get. So we've got 0 on one side already. That's perfect. I see that there is a common factor of 2 out front. So I'll factor that out. And the reason, remember, why we do that is that with the AC box method and with the bottoms up method, regardless of how you do it, if you don't factor out a GCF, it doesn't work properly. There's some problems that end up happening. So, but this thing does factor nicely. It factors to 2 times t squared plus 10t plus 25. And then this time, we don't even need to use AC box or bottoms up, really, because it's a linear like it's a quadratic with leading term 1, because it's 1t squared. So we want two numbers that multiply to 25, and the same two numbers need to add to 10. As a small aside, by the way, just because I'm realizing something, I upped the font of my pen strokes by 1. So instead of being at a font of 3, it's at a font of 4. Does it look better this way? Or is it indifferent? Like, do you see the difference between this one and this one? This is a little darker. Do you like it more with the higher? Okay, cool. So does anybody know the two numbers that work? 5. Both of them 5. 5 and 5 both work. So then this thing factors to, so 0 equals 2 times t plus 5 times t plus 5. Or we could write it, we don't have to write it this way, or equals 2 times t plus 5 squared. However you want to write it, I usually, like, the only reason why I'm reminding us that you can write is t plus 5 squared. That would be useful when we talk about nonlinear inequalities. But that's 5-6 weeks down the road. But it's still a good practice, just recognizing that t plus 5 times t plus 5 is the same thing as t plus 5 squared. So by the zero product rule, either 2 equals 0, but that's ridiculous. So we're writing that in our notes. We're writing that 2 equaling 0 is ridiculous, but on an exam, you can just skip that. I just want us to always be aware of it, because remember the difference. If it had said 2t times t plus 5 squared equals 0, then you would get a solution from that first set, right? So everyone see the difference? And it's okay to say that you don't. I can go through it. But the difference between 0 equals 2 times t plus 520 squared and 0 equals 2t times t plus 5 squared, the 2t can give you a solution. The 2 does not, because 2 can't equal 0. 2t can. But anyways, And then I'm just going to write uh, uh, t plus 5 equals 0. I could write t plus 5 equals 0 or t plus 5 equals 0, but then I'd be solving the same equation twice. No need to do so. So what we say is that t equals 5 is or the answer will be just t equals -5. We say that it's a repeated root, but that's for later on. But it's a repeated 0 because it gets done twice. Any questions on B? All right. We'll do C, which is 4b squared minus 11b every fire time. Yes, yes, I know. The next one, 4b squared minus 11b equals 3. So we've got to get everything to one side. So we'll subtract the 3 from both sides. We get 4b squared minus 11b minus 3 is equal to 0. And then I'm going to do the AC box method. Well, no, I did AC box in the previous one in part A. So I'll do bottoms up. So on the scratch paper or however I want to do it, I've got the new factoring, the new polynomial will be b squared minus 11b minus 12. If you remember the bottoms up method, depending on which method you want to do bottoms up, you combine the a and the c term and rewrite it as a new polynomial. You drop the a term on the b squared and go with that. We want two numbers that multiply to -12, and the same two numbers need to add to -11. And that would be -12 and 1. If memory serves, yep. Because -12 times 1 is -12, and -12 plus 1 is -11. So the new polynomial, the aside polynomial, is going to be b minus 12 times b plus 1. And then to convert it back into our polynomial, we divide by the a term and then bring the bottoms up after reducing. So the a term was 4. So this will simplify to 3 over 1. And then we'll bring the bottoms up. And so this thing will factor to 4b minus 3. B minus 3, excuse me, times 4b plus 1 is equal to 0 once the bottoms have been brought up. But if you want to use the AC method of trial and error, if you found some other method that works for you, be my guest. And then setting those equal to 0. So b minus 3 is equal to 0, or 4b plus 1 is equal to 0. And then we learned how to try and solve these ones quickly. So the answer should just be b equals 3 or -1/4. And I don't need, I know Alex is very, very particular about like most negative first, go from negative to positive, but that does not matter on an exam. I just want to see the solutions. Any questions on that? Yes.
You lost me on the bottom, so.
The b minus 3 equals 0 from here to here. Here. So that's the bottoms up method for factoring. So once you've found the factorization of the b squared minus 11b minus 12, which we found as -12 and 1, then we write it as b minus 12 and b minus 1. So there's an extra step that I tried to get this thing to be a little too chaotic, I think. So let me just bring this over just a smidgen. All right, and so what you end up getting once you reduce them, you get b minus 3 over 1 times b plus 1/4. And then the bottoms, like the bottoms up method, you take the bottoms of the fractions and bring them up. So that's why it becomes 1b minus 3 and then 4b plus that 1. That's the bottoms up method. But if you like the AC method more, like that will work too. And when it comes to exam time, by the way, if you can go straight from here, from b minus 3 times 4b plus 1 equals 0 to b equals 3 comma -1/4, that is totally fine and acceptable on the exam. Okay. Any other questions? Next one. Got negative 2m to the fourth equals 5m cubed. Sorry, there was that typo, plus 12m squared. So we need to get one side to be 0. Now, which side do we choose? It does not matter. However, I would argue, me personally, that we should bring everything to the right side and make the left-hand side 0. That way I don't have to deal with a negative leading coefficient. Just to write this down so you can see it. So if you bring it all to the left-hand side, you get negative 2m to the fourth minus 5m cubed minus 12m squared equals 0. And I don't like my leading term being negative. Now I could just factor out the negative as well. However, I will just caution against that just because it what did I forget? So
Plus
I think it is supposed to be a negative.
it is supposed to be a negative from the beginning? Oh. Oh, okay. I did not I didn't actually get a chance to check it this weekend. So maybe it works out that way. Thank you. So leading term being negative, not a good idea. At least in my opinion. It doesn't change anything, but I just prefer having a leading coefficient being positive. So I'm going to bring everything to the right. That way also I only have to do one piece of algebra instead of two pieces of algebra. So 0 equals 2m to the fourth minus 5m cubed plus 12m squared. Now, there's no number GCF. There's no number that can be pulled out of all three of the terms. No number, no integer that can be pulled out. But there is an m squared. So we'll factor that out. We get 2m squared minus 5m plus 12. Right? And then we've got to factor that. And this time I'll do AC box. I want two numbers that multiply to a times c. So that means I want the two numbers to multiply to 2 times positive 12. And the same two numbers need to add to negative 5. So that's what's tripping me up, though, here. Because if it was... Oh, it's not that the negative, it's that the 12 should be minus. I think that'll fix it. Because then it'll be negative 24, and then you can do 8 and 3. That's what it is. I apologize, guys. Sorry about that. Supposed to be minus 12m squared. So make sure, like if you wrote down what I wrote down, this sign on this first line should change to a minus here, and then a minus again here. Now with that correction, as long as everyone's chill with that, please raise your hand if you need me to slow down for a second. So then negative 8 and positive 3 will work. However, as an aside, like this would be a very mean thing to do on an exam, but if it did not work, claim that it's prime and so that we can't really find it. Or you could use the quadratic formula, but we'll see that in a second. So then that means we'll make our box here. So 2m squared in the top left, negative 12 in the bottom right, and then that negative 8m and that 3m. And then we look, if you're doing the AC method, but remember, you can use box method or the bottoms up method if you want. We're looking for the GCFs of each row and each column. So the first row should be 2m. Bottom row should be 3. First column or left column should be m, and right column should be negative 4. Yep. So we have 0 equals m squared times 2m plus 3 times m minus 4. So I'm going to do it this time, showing you what you can skip the work and write the answer, but I will write the intermediate step. But this is where you can get to it. I'd love for you to get to this point of just claiming that therefore the answer is m equals 0, negative 3 halves, and positive 4. But the reason why that's true, so hopefully you can see why it's true. And if not, by the zero product rule, either m squared equals 0, 2m plus 3 equals 0, or m minus 4 is equal to 0. And all of that information, m squared equaling 0 gives me the m equals 0 as a solution. The 2m plus 3 equals 0. I subtract 3 and then divide by 2. That's where I get the negative 3 halves. And then the m minus 4 equaling 0, I add 4 to both sides, giving me that answer of 4. Any questions? Yes, I'm aware. Just need to buy a new one. Okay. JT, do you have a question?
No.
You sure? It's okay.
Okay, I guess it's probably a dumb question. M
No.
squared. Like
Mhm.
obviously you're gonna solve it like. I guess there's not a different scenario where it wouldn't equal 0 because all of them have to equal 0.
I'm really glad that you brought up m squared equaling 0. I'm really glad. So why is the answer just like, how do we solve that? Well, technically speaking, just as an aside, so you could, and that would be fine. That's another way to solve it. Just take the square root of both sides. We talked about the square root property, plus or minus, right? But plus or minus 0 is just 0. There's no positive or negative version of 0. That is one way to do it. But the other way is, remember, m squared, that is m times m equals 0, right? So by the zero product rule, either m equals 0 or m equals 0. But I don't want to solve it twice, so I just end up solving it once. Same reason why I did for this one here. I could make it say that or t plus 5 equals 0. I could do it twice, but it wouldn't do anything. I'd just be writing the same thing over again. Excellent question. So whenever you have a squared thing and it's equaling 0 or whatever, if it's just equaling 0, then you can just say that whatever the factor is just going to equal 0. You don't have to solve it twice or 3 times or 4 times. Next one, there's a common factor of t, first off. So we can factor that out front. And then it's t squared minus 36 equals 0. But t squared minus 36 is a difference of squares. Very, very common thing. So that's the a quote unquote is t and the b quote unquote is 6 because 6 squared is 36. So this thing factors to t times t plus 6 times t minus 6 equals 0. So by the zero product rule, either t equals 0, t equals negative 6, or t equals positive 6. And then I think it was Mark, correct? Mark was asking about plus or minusing, and you can just write it as 0 comma plus or minus 6 on the exam, and I'll give you full credit. All right. Any questions on any of those? All right. So we've got 2 more to do, and I like you guys to do them just as a little fun aside thing. So I used to teach business calculus a lot when I was at OSU, because they always wanted me to be teaching. Like they made their I mean I hate to sound pompous. They made their better TAs do the lower courses. And so I never got to teach a calculus, but I did get to teach business calculus. And so one of the things you always do in business calculus is you use quantity as as a variable. And so usually use a Q for that. And that gave me the experience of saying Q cubed, which is just the most fun thing to say. Just say it in your head, Q cubed. Sounds way too fun. So every single time, I always try and make sure I have a Q cubed in a problem somewhere, some way in one of our examples. So go ahead and try and do these ones. I'll slowly fill in details. And feel free to ask a question. Like if you want me to come over there and help you specifically, I'm happy to do that. I remember this was cute. I've got the answer to part A up here if you'd like to check your work. We're going to talk about this one though, because there's a lot to discuss on it. Not a lot, verbally. But we'll talk about that one. And then we'll move on to part B. All right. I have the answers up here if you'd like to check your work. We're going to talk about part A real quick, and then we'll talk about part B. So I'm sorry if you're still working. Does anybody want a little more time? Thank you. UQ. UQ. My wife gets really upset when I do it because Q is a very, very bad variable because it looks like a 9 if you're not careful. Uh, but I can't resist. I just want to see how much we have. Okay, cool. All righty then. All right. So for the first one, as soon as I saw that there were 4 terms in it, whenever I see 4 or more terms, the first thing I want to think about is doing factoring by grouping. That little trick where you divide it down the middle and then you factor it based on that. So you find the mini GCFs from the first 2 terms, from the q cubed and the 2q squared. There's a common factor of q squared between that q cubed and that 2q squared. So I can say q cubed one more time. And then from the set that doesn't have a q cubed, we have that 16q plus 32. And that one has a common factor of 16. You factor that out front. And then you have a common factor of q plus 2. So you put that up front. And then what's left over from the first term is a q squared. And left over from the second term is that 16. So you have factored it, but you need to ask yourself, can I factor it further? But q squared plus 16, that is a sum of squares. And sums of squares cannot be factored over the real numbers. You have to extend yourself to imaginary numbers in order to work with that. So it doesn't factor. So therefore, by the zero product rule, we either have q plus 2 is equal to 0 or q squared plus 16 is equal to 0. Q plus 2 equals 0, that gives me q equals -2. Now, q squared plus 16 equaling 0, that's not possible unless we extend ourselves to complex numbers, because q squared will always be a positive number, or a number greater than or equal to 0, right? Because -1 squared is +1. -20 squared is +400. 0 squared is 0. So q squared is always greater than or equal to 0. And then I'm taking that number and I'm adding 16 to it. So it's always going to be a positive number. There's no way for it to equal 0. So it cannot be solved. The answers to it would be so we can even write this if we want. Answers will be complex. You will get q equals 4i and -4i, where I is the imaginary number. But once again, we do not need to solve that here. That's not part of the curriculum. But if you want to talk about complex numbers, please feel free to talk to me. I love complex numbers. Any questions on that? That one's a weird one because that q squared plus 16. Yes. Excellent question. So when we say for any q value, in the context of this problem, there is no value of q in the real numbers that will solve that. There's no q for which that's not true. For every q that you would choose, if you pick any q, this will always be positive. So in the what that means when you say for any q, it means in the context of this, it's true for any q. Yes. Thank you. That's me busting out some mathy language that needs to be broken down. Thank you. I appreciate that. Next one, we've got x minus 1 times x plus 2 is equal to 18. And this is always a trick, and they try and throw this at you, and we want to make sure we never fall for it. Is that in order to set factors equal to something, it has to be the 0 on that side. It has to be the 0 product rule. So we have to simplify that first. So we distribute or FOIL out on the left-hand side. You get x squared plus 2x minus x minus 2 is equal to 18. Bring the 18 over and simplify. The 2x minus x gives us a positive 1x. And the -2 minus 18 gives me the -20. And then we factor that. And it turns out to be 5 and -4 that multiply to -20 and add to 1. So you get x plus 5 times x minus 4 is equal to 0, which gives us x equals -5 and 4. Any questions on that? So please don't fall victim to that trap. I wouldn't be surprised if one of those shows up on the exam. So hint, hint, wink, wink for the people watching the recording, because you can't see me winking. There might be one. I can neither confirm nor deny the existence of it, but if I was a betting man, I'd say there might be one like that on there. Okay. So the quadratic formula. The quadratic formula. In order to talk about the quadratic formula, we need to do just a little small side definition. We say that a radical is in what we call simplified form. if the that's supposed to say if the number on the on this inside on the well, that's two typos, sorry. If the number on the inside which we call the radicand, just in case you want to bust that out in conversation to impress people. It's called the inside of a radical is called the radicand, but either way. But if the number on the inside is not divisible by any square numbers. So the rule for simplifying radicals is that the square root of a times b is equal to the square root of a times the square root of b. That's a true statement about radicals. There's a caveat provided square root a and square root b exist. That's just me being mathy. That's just, you don't even need to write that down. It's just in case there's a sleeper math teacher out there who's going to say like, haha, you wrote something that's not mathematically true. It is true as long as the square root of a and square root of b exist. If they don't exist, then this kind of falls apart. But point being is that you can combine, like, remember, this is true backwards and forwards. So if you have two radicals, you can combine them together, or you can take a radical of a product and break it up into two pieces. So square root of 125, that is not in simplified form because you can write this as the square root of 25 times 5. And so there's a square number that goes into 25. Square number that goes into 25. Into 125. So that's the square root of 25 times the square root of 5, which is 5 square root 5. Because the square root of 25 is 5. Lots of 5s. Good news is the calculator that I recommend, and I think even the TIs as well, they actually allow you, like if you put in square root of 125, it should actually simplify the radical for you. So don't worry too much about that. Just you use your calculator. It should do it. And if not, let me know and we can work together. The next one, square root 72, is also not in simplified form because 72 is divisible by 9, and 9 is the perfect square. So you can rewrite this as the square root of 9 times 8, which is going to equal the square root of 9 times the square root of 8. And I'm actually not done yet because this is equal to 3, but square root 8 can actually be simplified as well because 8 is a product of 4 and 2, and 4 is a perfect square. Can go further, so this is going to be 3 times the square root of 4 times 2, which would be 3 times the square root of 4 times the square root of 2. And since this is 2, and feel like, so I could have done this actually more cleverly and realized that 36 divides into 72. And then I'll get the same answer, but I did it the long way just to practice our algebra and arithmetic. So breaks it up, and then 3 times 2, that's 6. So this simplifies down to 6 square root 2. Now that's just doing it with basic radicals, quote unquote. We're going to be more interested in seeing things like 6 plus the square root of 24 over 2 and trying to reduce that. So 24 is not in simplified form because it's divisible by 4. And 4 is a perfect square. Yes, JT.
So where'd you get the 6 from?
Oh, no worries. There's this multiplication.
Okay.
That kind of made that way too hard to see. Let's use maybe green. And then that gives me the 6. Is that okay?
Yeah.
That was a long-winded process, but please remember that your calculator will do this for you. It's just mainly mentioning that you can reduce radicals. I just wanted to talk about that radical property, that you can split apart radicals. That is mathematically valid. So This one right here, just in the, so I'm going to put this on the side here. So square root 24 is equal to 2 square root 6. Take a second to make sure you understand why that's true. Take a second. I'll explain it in just a moment, but I'd like you to try and fill in the detail. Why would it be 2 square root 6? And that's because square root of 24 could be rewritten as the square root of 4 times 6. Square root of 4 is 2. Square root of 6 can't be reduced. There's no perfect number that goes into 6. So this simplifies to 6 plus 2 square root 6 over 2. We can simplify this further. Because remember, if you're dividing by something, it means you're going to divide each thing by it. It's the distributive property. So the 2 goes into 6 and it goes into 2. So the way we typically write that would be, if we want an intermediate step, that would be 6 over 2 plus 2 square root 6 over 2, which would finally equal, so the 2 and the 6 would cancel a little bit, and the 2 and the 2 would cancel. We get 3 plus the square root of 6. Sure, I'll use a circle that time. Yes, JT.
Why are we not adding the 1? 3.
1 with 3. The 1 square root 6? Which sorry, this one right here. Excellent question. Excellent question. So why is it that we cannot do, so we can't combine them any further than this? And so there's a terminology that we call it. So in with regards to it, we need like radicals. So there are like just like there are like terms, there are things called like radicals. And in order to combine things that have radicals, they have to have the exact same radical portion. So we can't combine because not quote unquote like radicals.
Radical 6, it wouldn't be.
Yes. So like JT asks an excellent question. So if it was 3 plus 10 radical 6, it would stay like that. We cannot combine them. But if it was 3 radical 6, we can combine them. And this would be 13 square root 6. Does everyone see the difference? So if they have the same radical portion, treat radicals kind of like variables. That's the only way we can really combine them. So maybe I'll even write that. Radicals are like variables. All right. So the reason why we're talking about that is because of the quadratic formula. What's right here is a very, very useful formula in mathematics. It says that for any quadratic equation, as long as you've got it in the proper format of ax squared plus bx plus c is equal to 0, one side needs to be 0 in order for this to be true. You always have to have it in that format. Then the solutions are x equals, it's going to be a big fraction, so start writing in the numerator. It's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the formula. That is the quadratic formula. And I'm of the opinion nowadays, like I used to be of the opinion that you had to have it memorized. I'd like you to, but I don't expect it. So if you have a brain fart during an exam, you can ask me what the quadratic formula is and I will give it to you. Um, just knowing how to use it is the key thing here. But there is a mnemonic device. There's a way to memorize it. All right. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you. There you go. I have a beautiful voice. I know, I know. That's the one time I will sing it. Can't ask me to do it again, but then again, I guess I'm recording this, so it's time immemorial now. So you can go back and listen to me singing that. You can use that to you can snippet that out of YouTube and then use that to lull your kids to sleep. I sing that to my son when he go to sleep. Good one to do. He actually knows it. Just silly. He has no idea what it means, but either way. The reason why it works, there's a proof of it, and I'm happy to show it to you maybe before or after class. But there is a reason why it works. Now, just a couple cool things about this, just to gush about it for a second. So there is a quadratic formula. There is a formula. This solves any quadratic you can think of. So no matter what happens, this solves it. There's also, in mathematics, there's a cubic formula. It's far more complicated and far less nice. I mean, even this is pretty nasty, but the cubic formula is even worse. But the interesting thing is that there is no formula for degree 4 and above. There's no quartic formula, there's no quintic formula, there's no hexic formula, there's no heptic formula. There's nothing besides the second and the third degree polynomials. And the proof of it had to do with a guy named Emmanuel Galois. I think did I talk about Galois in this class? I don't think I did. Very famous mathematician. He was 19 when he created his thing called Galois theory. And then he got into a duel over a love affair and ended up dying during the duel. But he wrote down all his findings and gave it to his best friend, and his best friend sent it to several main mathematicians. It got lost in the mail like 3 times. And then one mathematician just said, okay, I'll look into it. And we still study it to this day. It's a big part of a field of mathematics called abstract algebra. So if you decide to become a math major, you study it in that class called Galois theory. Nowadays, like he discovered it when he was 19. So makes all of us, the rest of us mathematicians, look like chumps, right? And it's a shame that he died, not because that he actually died, but because he could have made more mathematics if he had lived longer. That's the reason why I'm upset about him dying. Not that I feel bad for him dying, but that he could have made more mathematics. I'm kidding, of course. But fascinating little story about him that he ended up dying in a love affair duel. But he was the one who actually proved that there is nothing for a degree 4 or a degree 4 or above. So that's pretty cool. That's kind of random that that's why it happens. Why is it only degree 3 and below? So either way, that is the formula. There's also a dope song on you can get it on Spotify or you can just search it online. There's a quadratic formula song. I'll play it during the break. It's just a bop, as the kids say. But that's the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So to use it in action, and then we'll take a break. So here, I'm doing this on the side. This is something I'm doing in my head. I'm identifying, this is already in the right format. It's already in the format of ax squared plus bx plus c is equal to 0. I know it's minus 5x and it's minus 4, but that's really just plus negative 5x and plus negative 4. So your a value here is 6, your b value is negative 5, and your c value is negative 4. So by the quadratic formula, x is equal to negative b, so that's negative negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times ac, so times 6, and then times negative 4, all divided by 2a, so 2 times 6. Now we got to do a little bit of reduction. reduce this down into something that we can work with, because that's a little too annoying to write out. And if you like, once you get comfortable, you start to realize when so the -5 just becomes a +5, right? Because the negatives cancel out. So if you want to skip writing -5, you can just write +5. That's fine. So this then becomes +5 plus or minus the square root of, let's see here, bust out a calculator because I don't want to do that math in my head. So 5 squared is 25. Minus 4 times 6 times -4. That gives me 121 over 12. And then if you know your perfect squares for a little bit, you might know that 121 is 11 squared. I wouldn't expect you to know that, but that'll equal, so that's 5 plus 11 over 12, a plus or minus, excuse me. And then we can reduce this. This means, so it's the plus or the minus version. So that gives us two answers. Either it's 5 plus 11 over 12, which would be 16 over 12, which reduces to 4/3, or it'll be 5 minus 11 over 12, which will be equal to -6 over 12, which is -1/2. And those are our answers. So the thing is, as a small aside, you on the note, I've already written it down, but you could factor to solve this one. This one was not like this, didn't need the quadratic formula to solve it. So you don't have to do it. You can factor it instead, and you get the same answers. So then why bother using it at all? Why would we bother using one or the other? Well, the quadratic formula, so the reason why we want to factor it is for later on in linear inequality and nonlinear inequalities. And if you plan on taking calculus, you use these things called sign charts as well, just like we're going to be doing in 2.6. But factorization really helps in that aspect. So that's the good thing about factoring, but it takes longer. The good thing about quadratic formula function is that it does give you the answers right away. But the big reason is that it can be used to solve something when it's a prime polynomial. So for this one, we can do it again. Oh, wait, actually, let's take a break. Let's come back at 10:05. Right, we got that, and we're done. So, okay. So 10:05. People watch the recording, go do some guided meditation or some yoga or some stretching, whatever you want to do. And all right, we're back. So during the break, we heard the song, the quadratic formula, bust it out whenever you're having some fun. Like next time you guys are on a road trip with your friends and you get the chance to choose the song, choose that one. It's a bop every time. It's my go-to choice. That or what's it called? Rollin' by Limp Bizkit. Did you guys know that Limp Bizkit came out with a new album? Do you guys know that? Does anybody know who Limp Bizkit is?
Oh, yeah.
None of you guys know what Limp Bizkit? Okay. Really? You see? Really? Metallica's playing with him? Awesome. That's amazing. But like I thought Limp Bizkit was dead, man. But they're new metal, NU metal, like the rap metal and stuff. But not the best rap metal. That would be Rage Against the Machine, but I'm biased. Anywho, I'm getting sidetracked. What was I saying? Oh yeah, that's the song you should play when you're driving. Okay, so now the big reasons that you want to use the quadratic formula is if you cannot factor it by hand. So if you try every avenue and you notice that it's prime, the quadratic formula will solve it. So for us, A is equal to 1, B is equal to 6, and C is equal to 2. And once again, I'm writing that in our notes, but on an exam or when you're doing it in your homework or whatever, you can just jot it down. You don't need to, you can keep it in your head. Doesn't need to be written down. But then X is equal to negative B, so -6 plus or minus the square root of B squared, so that's 6 squared, minus 4 times A, which is 1, times C, which is 2. all divided by 2a. So that's 2 times 1. And if you want to skip some arithmetic, like if you wanted to write that, if you wanted to immediately go to this, -6 plus or minus the square root of 36 minus 8 over 2. You could have just as like you could have done that, and I would have been happy with it. Like if you want to do the arithmetic in your head, so 6 squared, 36, 4 times 1 times 2 is 8. That's fine. Please do so. And so that will be 28. -6 plus or minus the square root of 28 over 2. But 28 over 2, that's going to be 2 square root. Wait. 28 is 4 times 7. So this should be 2 square root 7. That takes practice. That takes practice to get there. But the reason for it is square root 28 is equal to square root of 4 times 7. And then you can split that up into a square root of 4, which is 2, and a square root of 7, which is in simplified form. There's no nice square numbers that go into 7. And so this becomes -6 over 2 plus or minus 2 square root 7 over 2, which will simplify to -3 plus or minus square root 7. And that's our answer. Any questions on that? The other reason why I would have used the quadratic formula is especially if I'm on a time crunch. Like I've got 5 minutes left on the exam and I need to find the solutions. And this one right here. So if you wanted to use the AC method or the bottoms up method, you need to find two numbers that multiply to 12 times 21, which is 252. And the same two numbers need to add to 37. Trivial, my dear, of course. Super easy to do. No, I don't want to go through all the factors of 252 and try and figure out which ones add up to 37. So this would be like, this is way too tedious. OUS, no. So this would be an option to do the quadratic formula. So once again, if you want to jot it down, you can. The A value is 12, the B value is 37, and the C value is 21. So X will equal, or in this case, it's Y in this equation, but it doesn't matter. Y equals -B, so -37 plus or minus the square root of 37 squared minus 4 times 12 times 21. So that's 4 times AC. A is 12, C is 21, all divided by 2 times 12, 2A. Please use your calculator on this one. I don't want you to try and do 37 squared minus 4 times 12 times 21 in your head. So you should get, therefore, you should get -37 plus or minus 19. The square root of 37 minus 4 times 12 times 21 gives you 361, which is a perfect square. It's 19 squared. So you get -37 plus or minus 19 over 24. And then that gives us two solutions. That's -37 plus 19 over 24 and -37 minus 19 over 24. And if I plug those into my calculator, just so I don't have to deal with like simplifying it myself. So in the numerator, -37 plus 19 over 24. I end up getting -3/4. And with this second one, All I need to do is just go back into it and change the plus to a minus, and I get -7/3. And those are my answers. Amazing. It gave me a pentagram or a pentagon. Yes.
For example, which wants to like those that route to do y equals and then those.
Yeah, but like we've got this. I'm glad you brought that up. So we've got this string of equalities, equals, and I should have written an equals here. But I was really just kind of saying this goes to that step. I'm fine with that logic. If you want to be very particular, you'd say y equals those. But the question says solve for it. Those are the numbers that work. So you have solved the problem. And if anybody has a problem with that in your future math courses, let me know and we'll bust out the sword of Gondor and I'll get to fight against JT.
So my calculators gives me like decimals instead of fractions. Is it okay to use that on tests and stuff, or do you want it in fractions?
If it can be written as a fraction, let me see that calculator real quick. I think that thing has an ability. Okay, so if you press second, that F to D, that means from fraction to decimal. And then, so I can give it however you want. So there's the calculators usually have a button that either says F to D, double arrow D, or it says S double arrow D. Depending on the calculator you have, that means going from standard form or fractional form to decimal form. So that's a way to utilize it to convert. Yeah, of course. All right. Any other questions on that? So it can be used if you really don't want to sit down and try and find all the factors. But the shortcoming of the quadratic formula is that the quadratic formula does give you the answers. It does give you the solutions to that quadratic equation, but it doesn't directly give you the factorization. So you can figure out a way to do it. There's a way to convert it. You'll notice that, so the solutions are y equals -3 minus 4 over 4 and -7 over 4. If you take the time, you'll notice that this actually factors to 4y plus 3 times 3y plus 7. And that's a nice nifty trick, because you notice, like, this is the solution when you solve the linear equation that comes with it. And it becomes 4y. I guarantee if you FOIL this out, you'll get 12y squared plus 37y plus 21. And so that is a nifty thing that you can do, but that is the problem with the quadratic formula, is it doesn't give you the factorization outright, which can be problematic when it comes to nonlinear inequalities. And if you plan on taking calculus, once you get to applications of derivatives, it'll become problematic. So it's useful. So if the problem is just asking you to solve it, feel free to use the quadratic formula. It works. But if you're going to need the factorization for something, probably best to use factorization. So it's good to be comfortable with both. If you don't want to use the quadratic formula, you don't have to. I like it as a good checking tool. Like once you've done all the factorization, you get your answers, check it in your calculator with the quadratic formula. So these ones here, we'll go ahead and solve them. I'd like you guys to work through them. But remember, the quadratic formula only works if it's all the terms on one side, 0 on the other. So part A, we need to do a little bit of work. Pause it so that people watching the recording don't have to sit and wait. I forgot to restart it so that I didn't show the steps. negative b plus or minus the square root of b squared minus 4ac over 2a. Dope song. Super awesome song. All right, I have the answers up here if you'd like to check your work. I'm going to go back to parts A and B because I want to talk about something real quick. Can't remember. Oh well. Would anybody like a little more time? Thank you. Okay, so with part A, so we got to get everything to one side. And if you want to skip steps, please be my guest. So notice that it's t equals 7. I kind of skipped the negative b and I just wrote it as positive 7 because it's going to be negative 7 plus or minus the square root of b squared minus 4ac. It's going to be 49 minus 20, which is the square root of 29. But 29 is not does not have any perfect squares that go into it. So that's already simplified. But you can use your calculator. If you put in square root 29, it should just come out back out as square root 29 divided by 2 times 5, which is 10. And so you can either write it as 7 plus or minus the square root of 29 over 10, or you can distribute the division of 10 through. Either way is fine. And that's our answer. So you got 2 unique answers. Whereas in part B, when you do it, it's already everything's on one side already. And when you calculate it, you end up getting that the square root is 0. And so plus or minusing the square root is 0. That's adding 0 or subtracting 0, which doesn't do anything. So we just end up with negative 12/18 over 18, which simplifies to negative 2/3. So this time we only get one solution. And it just so happens that if you were to factor this, you'd notice that this is actually equal to 3x plus 2 quantity squared, which is why it only comes up with one solution. So that's the reason why it ends up just being 1. And then in part C, you end up getting non-real solutions. So if you try and plug it in, I brought everything to one side. JT correctly identified that I made a mistake in the denominator. It was supposed to be 2 times 2. That's your A term is 2. So you get -3 or just +3 plus or minus the square root of 9 minus 40. So you get -31 all over 4. And the square root of -31 is not a real number. So it depends on the context. If it so for us, once again, we're not dealing with complex numbers. So the answer will be no real solution. But if you really want to, there are solutions. They're just complex. They're 3/4 plus or minus square root of 31 over 4i, where I is the imaginary number. But I would accept on the exam just writing no solution, no real solution. And then the last one, this one, we have to do a little bit of algebra. We need to do some simplification. So I brought everything over to one side. So subtract the x squared and added 2x. That gives me 1x squared now, plus 6x minus 1. My a value is 1, my b value is 6, and my c value is -1. Plugging it into the formula and simplifying, I get -6 plus or minus the square root of 40 over 2. If you feel comfortable going straight from here to here, please be my guest. I'm totally fine with you skipping writing this out. It doesn't hurt to write it out so that I can see if there's any mistakes, but you can go straight to it if you feel comfortable. Square root of 40, that can be simplified because that's 4 times 10. And so that's a perfect square goes into it. So that's the same thing as 2 square root of 10. You can divide each thing by 2. You get -3 plus or minus the square root of 10. So I just wanted to kind of bring this to attention just as an observation, just a cool little observation, unless there's any questions on any of these. It's okay if there were. I realized I should have stopped after each one. I didn't. Yes.
If we stopped at, on question C,
Mhm.
if we stopped at 3 plus minus square root of -31 and 4, is that okay? Or we only get like half right?
So like for this class, I'd rather like you to write no real solution. If you write that as your answer, I don't know. I'd probably be fine with it. I doubt one of those is going to show up because I'm trying not to we're not going to really do complex, but I did want to bring it up as an informational item is that you can get complex roots. And so you'll notice that you either get 2 solutions, 1 solution, or 2 imaginary solutions. And that has to do with this part right here. This thing right here, this b squared minus 4ac. If you want to write this down, it's not going to be tested on, but it's just a cool thing. The discriminant is the b squared minus 4ac. It's a thing we study a lot in upper division mathematics, specifically when we study Galois theory, is that b squared minus 4ac. If b squared minus 4ac is greater than 0, then that'll give you 2 real solutions because you'll be taking the square root of a real number and you'll be adding or subtracting it, giving you 2 different options. If b squared minus 4ac is equal to 0, then the square root goes away and you get 1 solution. And then if b squared minus 4ac is less than 0, then the inside of the radical would be negative, leading us to complex numbers. So the discriminant, it's strange how often this shows up, the discriminant in different theorems. In differential equations, the solution sets to certain things end up having to deal with the discriminant again. In Calc 3, you learn about a thing called the second derivative test in multivariable, and it ends up actually being using the discriminant to prove it as well. So it's very fascinating, but not necessary for us. You'd only really need it if you were going into being a math major to talk about the discriminant. So just as a fun little side note, but other than that, any other questions? Because if not, that completes all the material for Unit 0. So the exam 0 will cover all from 0.1 up to 0.6. 0.7 we'll do next week. 0.8 will be done in about 6 to 7 weeks time. So we don't need to worry about those for now. On Monday or on Tuesday, so tomorrow, we'll be going over Unit 1.1. I believe Unit 1 notes are already posted, but if not, I'll post them tonight. So please print off 1.1 because that's what we're going to be going over tomorrow. But please note that 1.1 is not covered on exam 0. It's just we're starting up the new unit. Normally, like for this course, every other exam we're going to have a review / catch-up day. But just based on how the cards fell, I couldn't put an extra review day today, so, or on Tuesday, so we have to go over new material that day. But just know that 1.1 is not going to be on the exam 0, okay? So any other remaining time, we can talk about any questions you have about the upcoming exam or any review. We can go over the review. We can ask him questions or anything like that. But otherwise, we're all finished for today, technically speaking. Yes. It's throwing in other things too. It might go over things that aren't necessary, but at the end of the day, anything that was anything that was on Alex is something that you need to know how to do. And so even if it's not a question that shows up on the exam, it's still good practice.
How do you see your?
For B? For D. Absolutely. So yeah, exam 0 going to be about 5 or 6 pages. That's usually the length of my exams is 5 to 6 pages. There'll be a cover sheet where you'll write your name, and that's where the score of the exam will show up. And then there's going to be a piece of scratch paper on the back. You're more than welcome to just rip it off at the very beginning and start writing on it. If you want to do any scratch paper, my request with scratch paper is if you are going to use it, make sure that anything that's important from it is put onto the exam. Because I typically throw away scratch paper unless like if it's attached to the exam, I'll keep it. But otherwise, I'll probably just throw it away. So make sure that anything that was important from the scratch paper has been transferred over. So like if you did the factorization, make sure the factorization has been put onto the exam. Don't just go straight to the answer if it's an equation. Expect to see several equations, expect to see several factoring problems. That's kind of the big stuff that I like, heavy emphasis on that, but also solving linear equations and simplifying algebraic expressions. All those things will be useful. Yeah. Any other questions? Okay, guys. Well, that'll do it for today. I expect I'll catch you guys tomorrow. If you have any questions in the meantime, feel free to email me or come to my office hours, and then I'll see you tomorrow.